We have around 640 members, combining 360 professional members and 280 student members from 4 student chapters. So please note that we still have around 55 professional members who have yet renewed their membership. So please check your membership status, and if that's and please consider to renew it. And if you just recently moved to Bangkok as well, what I did 3 years ago is you need to go to the SPE.org to update, where is your section. So please select Thailand section. And to all of us, our membership, depends on your support. So please do encourage your colleague to join our technical monthly meetings as you are joining here. And even better to encourage them to join SPE because we always need new members in SPE. Our SPE Thailand section monthly meetings are legendary in the region. I'm just reading from the script. And provide an excellent opportunity to network, to relax, to eat and drink with like-minded professionals. I do agree that, and I really appreciate the efforts from the committee since I came to Bangkok 3 years ago. So please, a round of applause to the SPE committee as well to organize these meetings. So I won't read the slides, but staying on the topic again on joining SPE as a member, there are plenty of reasons. Now, it's worth mentioning that being in Thailand SPE section, you have regular opportunities like this to network and to share information and knowledge and socialize with our peers of our industry. And again, SPE Thailand section is very proud to be one of the most active SPE sections in Southeast Asia. And that is thanks to you and our sponsors, and of course again our efforts of the volunteers in the committee. So again, an applause to all the sponsors of SPE and also to the committee of Thailand section, please. Too many clapping. Without our sponsors, our current format of these meetings would not be possible. And if you would like to see your company name in here, please reach out to any of our committee members there. Everyone in this room will really appreciate your support. Okay, then let me hand over to the microphone to our program chair, Kun Kasian, who will do the honor of introducing our speaker.
Do you still need this?
No.
Okay, I'll just leave it here.
Okay, thank you.
Thank you, Sen. Thank you very much. All right, for those who doesn't know me, my name is Kasi and I'm the SPE Thailand Program Chair. Once again, we saw a lot of new faces today. Everyone is welcome, and also sponsorship are welcome. Once again, we are hard sell people here. As Sen mentioned, right, we wouldn't be able to deliver this kind of professional setting for you to be. A lot of you came in for free. Some pay just a little bit to have a good wine, good drinks, good food, and then enjoy the new knowledge. So much appreciated. Okay. So anyway, me and Ron Ford were just talking about this earlier as well. I think it's as a traditional now, we always have the joint meeting between SPWLA, Bangkok chapter, and SPE Thailand every year, once a year. But our members' interests are very common, and most of them. So we're just thinking maybe we should do twice a year. Ron Ford is there and he's supporting it, so we're considering. Okay. So anyway, without further ado, let me start to introduce our speaker this evening. So our speaker has over 33 years in the wireline business, where he started life as a field engineer with Gerhardt Industry in the 80s. Our speaker has authored and co-authored multiple SPE and SPWLA papers over the year, with a recent focus on well integrity applications. Our speaker is currently the Technology VP where he supports the global customer bases and leads their technology development program. Ladies and gentlemen, please join me for a very warm welcome of Kun Marvin Rourke, VP Technology from GOWell.
Get this working. Hey, good evening. So thanks for the joint invitation, or the joint invitation to the joint meeting today. I mean, SPEE is also known as the guys and the girls that look at squiggly lines. So bear with me. We do have quite a few logs to look at today, but I will try to get through that as quickly as possible. So life after casing, not life after retirement. I know some people are, that includes some people here. You know, I want to talk today about the, you know, the life cycle of the wells after, you know, after the casing has been run and after many years of life. And specifically through tubing inspection. That's the title of my talk. But just to get us going here, I'd like I have a little quiz, or a little I don't get it going here. Okay, so this is an incident that happened probably 7 years ago now. I don't know if anyone is aware of this well integrity issue that happened in the US in around early 2016. It was a significant issue or significant blowout that occurred in California in this Allison Canyon well. It was kind of called the invisible catastrophe because it didn't catch fire, and there was not a huge public media attention to it, but it was extremely costly to correct. They had to drill a relief well to kill this well. It's actually a gas storage well that had been repurposed from an old and depleted oil field, and there was a very long investigation. So it actually happened 2016. You can't really read that there. The actual report came out in 2019. It's public knowledge. You can go and download it. It's 200 and something odd pages. But you know, the actual summary of what happened is kind of down here, and you know, it blew out for 111 days of an uncontrolled escape, and about 1,000 families had to move away because this was on the outskirts of Los Angeles. And you know, when they looked at it and went back and analyzed it, you know, this was related to a well integrity problem, corrosion in the casing that allowed the gas to escape on the outside, eventually on the outside of the conductor pipe, and as I say, they had to drill a relief well to kill it. You know, these type of events, you may not have known about this. It was very public, but there are many other events similar to this that occur worldwide. Unfortunately, still happening today. A lot of them go under the radar, as it were. They don't catch the public eye as much as Macondo did, for example. But all of these could have been prevented. So today we're going to talk about a little bit about, you know, kind of technologies that are out there today. This is actually an example, not that example, but a similar example from California, and a well that is being monitored as a as a result of the Allison Canyon incident. Now the operators are taking much more concern and much more importance played on surveillance, and this is a well that has a problem, and it's under investigation. So what are we really talking about today? We're talking about measurements for casing and inspection techniques. And I've split it here between what I say direct access to the pipe. So that's very common. You know, you can run different type of tools in your well, whether it's multi-finger calipers or flux leakage tools or ultrasonics, and you have direct access to the casing that you want to measure. That's been around and been done for many, many years. Video cameras as well, for example, in gas wells. You know, where the difficulty is if you want to see beyond the pipe and see behind the pipe, and be able to monitor what's happening in your second, third, or even fourth casings. You know, how do you do that? You got to look through. You got to look through the metal, and you got to be able to make measurements behind metal. Right. So that type of measurement is way more limited. You know, we have temperature is very common, you know, and in fact in the Allison Canyon case, the regulations at that time said you had to run a temperature log every year. Right. Well, of course, by the time you have a leak, it's a bit too late. So temperature is kind of a reactionary thing rather than a proactive. Electromagnetics, you can look through metal with electromagnetics, which we'll talk a little bit more about. Noise, you know, kind of you can imagine you can listen through multiple pipes, so there is propagation through there. X-rays, like you do at the airport, you can see through things. Gamma rays, and actually low frequency acoustics as well, and this is something that's coming along in development. So we have more limited physics measurements we can make. One of them is electromagnetics. So I mentioned that we're going to be looking at squiggly lines. Here we've converted that into a picture. That makes it a little easier for you to understand. You can hear okay? Or?
Maybe closer to the mic.
Okay, sorry. Are you hearing me okay now? Yes. It's better? Okay. I'll move it closer, yeah. Right. Okay. So, you know, we have some types of logs that can look through multiple pipes. This is one very simple example. It's actually a surface test, and we know exactly what was happening because, you know, they were, you can see from the photographs, there was some metal loss that was machined into those pipes. Very simple kind of display here. Green, you know, green is good. You know, blue is metal increases, that's usually the collars, and red is not good. That means you've got some corrosion going on there or some thinning of the pipe. So you can see in this case we have a way of differentiating between inner and outer pipes. In this case, very simple. There was two pipes, the inner pipe and outer pipe. We can see corrosion that's happening on the inner pipe, and we can see corrosion that's happening on the outer pipe. So this is a type of technology that can be used to look through your first pipe, tubing or casing, and look beyond. This is an example actually from Canada, where they have a lot of steam wells, huff and puff, where that puts a lot of strain on the casing. You know, the operator used to be having to pull the tubing and go and run a log in the casing to detect the casing breaks. But now we can do that through tubing, so they can go out on a rigless and be able to run a log and actually determine a casing break through tubing. These breaks typically happen at the collar connections. There's a weak point, usually right here or right down here somewhere. And as I say, when they thermally cycle these wells after multiple thermal cycles, then you end up with a break. Here, this is just a caliper log that was run after they pulled out the tubing, just to verify that there was actually a break right above this, or right in this collar connection. But we can actually see that, as I say in the previous slide, we can see it we can actually see it right here and detect that through the casing. Some other examples. This is quite common that occurs in the Middle East. We have aquifers, highly saline, relatively shallow behind the either the surface pipe and the intermediate pipe and the production pipe. And what's happening here is this is a case where things got really bad, and there was a log that was run inside 7-inch casing. They identified a hole in the 7-inch casing that was right here. But the log over here shows a lot of red. This is what this is basically telling us is that the 958 behind was extremely corroded to the point that it was a hole through the 958 and it starts to finger to the 7-inch and eventually puts a hole in the 7-inch right here. You know, if you're only running a log like this, you know, by this time it's pretty much too late. You've already got a significant well integrity issue right there. But if you run these logs in surveillance modes, you know, we can see this occurring, and it's quite common that they would have, they would have identified this earlier and put a scab liner or something to repair that well before it got this bad. Another example, 7-inch 958s. They logged, They logged in the 7-inch casing here. These are the 7-inch collars. These are 958 collars. Significant corrosion here that's occurring in the 958s. This customer here went ahead and cut the 7-inch, pulled out the 7-inch, and then went ahead and logged a conventional log inside the 958s. And sure enough, you know, a lot of corrosion that's going on. This is the thickness image here. A lot of corrosion going on. This example I pulled because this is very similar well schematic to the Allison Canyon well, where just below the conductor pipe there is this significant corrosion that's going on here. In this case, hadn't got as far as a 7-inch yet, but you know, if you waited long enough, then you would have had exactly the same scenario where the 7-inch would have leaked right through to the 958s. And you know, usually these surface casing, the cement bond, if it's even cemented, is usually, you know, typically very poor. So once you've got pressure here, you've got escape up to the surface. Another well, this is just a very simple example, but this is a well where you've got multiple pipes from 4.5 all the way through to 13.3/8. You know, sometimes you want to do a sidetrack. You want to make sure you're going to pick the depths of the kickoff point or the whipstock setting depth. It can be helpful to understand where you are in the well, looking at the collars. This is an example. I like to use this one. Very old well from in Australia from 1924. It was abandoned well, an orphan well, one of these wells that nobody owns. They identified that they had significant well integrity issues, since they've got, you know, they could hear that there was leaks going on in the at the wellhead there. Let's say there was no records of this log. No one really knew what was in the well. So we went down and you know, identified that, yeah, there's significant corrosion here. There's actually a bottom of a casing or something changes significantly there. As I say, they didn't know what was really in the well. You know, we got a scrap of paper that said, well, maybe it was, I can't remember even now. But there was an interesting backstory on that well about, you know, the guy that drilled it, and took him 12 years to drill it. There's a reference here. You can go and look it up and learn all about that old well. And of course, there is hundreds, if not thousands, of these orphan wells all over the world that need plug and abandon. and understanding corrosion in those wells to properly plug and abandon them is very helpful. This is another kind of interesting case. This is a pure CO2 producer well, and why it was interesting is that the output of this well goes straight into the Coca-Cola factory that has been producing for many, many years, and there's also a backstory to this well as well. There's a reference there. They call it the curious case of Caroline. The long story short is, yes, they had some significant corrosion problems in this well that they had to go and look at after, I think it was, well, you can see, drilled in 1966, and it's been producing CO2, very pure CO2. But the backstory on this well is that the fact that CO2 has been captured naturally in a well bodes well for for CCUS, carbon capture, which is the reverse, where you're putting the CO2 back in the ground, and this is naturally occurring in the world, so we know it can be done. You can take some lessons away from that. But similarly, whether you're dealing with a CO2 producer or a CO2 sequestration well, corrosion that's occurring, particularly shallow. This is very shallow, from aquifers there, groundwater. If it's this shallow, you get a lot of microbial corrosion that goes on that has to be taken care of, and particularly if you're repurposing old oil fields, maybe for carbon capture, this problem is more pronounced. So moving over to other technologies, as I mentioned earlier on, we have EM, which we've covered there, looking at corrosion. We also want to be able to detect leaks. Corrosion is good to predict beforehand, kind of a proactive approach to monitoring. But sometimes you'll have pressure in the annulus. You want to be able to evaluate that. So noise, why is noise? As I said, is because it can pass through the pipe. You can hear activity that is occurring behind pipe, leaks that are in casing, for example, or leaks from packers and such like. So noise is not new. It's been done for many years. Some of the very old hands may have experienced listening through headphones to essentially a downhole microphone and listening. It's got a bit more high tech these days where we can make those measurements and display the logs, but the same principle applies. So leak detection through multiple tubulars, say all sorts of different potential problems. Sustained pressure, annulus pressure, whether that's your TCAs or CCAs, good way to diagnose that. But you can also use that for cross flow, looking for activity behind pipe. Maybe you've got a low pressure zone that's taking fluid from a higher pressure zone up above, and it's flowing behind the pipe. You can also, that's due to that could be due to channeling in your cement, for example, cross flow, and in some areas, even looking at fracture flow and looking at better qualifying your some reservoir information through fracture flow. So this is an example of simple example of leak detection. This well, there was a 958 casing. There was annulus pressure between the 958s and the 1338s. Very clear. This is the noise log over here. So this was logged in August in the 958s. There was, clear. One of these is shut in. One of these is the well was flowing, and identified a leak here. The operator, took many months, but eventually were cut the 958s, pulled the 958s, and then they actually logged a caliper, which can, obviously direct contact the 1338s. They identified a hole right there, which corresponded exactly where the leak was occurring that was measured back, a few months earlier on. So just an example of not only the type of through tubing log that we can use for leak detection, but also some verification. This is a log from this part of the world. I put this in here because this is also interesting. There is a little video that goes with this, so I think we can clearly see some gas bubbling around the wellhead in the cellar here. You know, when we went down, we can see the activity very shallow that's escaping here. So something's going on in the well here where activity is escaping up, and so this is the point that it's passing through the pipe. But there's also some indication that it's moving up and moving down at very low frequency here, which is very typical for cross-flow type of information. So again, this is obviously something that you really don't want to be happening to your well. I mean, and there has been cases here, I think in the Gulf of Thailand, where this is bubbling at the mud line subsurface, and the ROVs can see that. So this is another example where eventually the operator actually pulled out the tubing and actually wanted to verify the actual leak problem. So in this case, again, there's some little videos here. There were actually two leaks in this well, one pretty clear, a humdinger as it were of a leak right here, and something that's slightly very clear but not quite as loud, as actually not quite as aggressive, the leak. So when they pulled it out, you can see on this upper video, you can see the leak that's occurring right here, pretty clear. It's flowing through the connection. So this is a collar connection on the tubing, right? So this is pretty common. If you see a tubing leak, most of the time it's going to be right at the collar connection. I mean, you may have a hole in the tubing, but what we typically see is that. And down here is going to be a smaller leak. Let's see if this. So the guy's kind of pointing with the stick there. You zoom in, you can see kind of dripping coming out of the connection right there as well. Just pretty slow leak. So gives you an idea. This obviously is pressured up here with water on the tubing, and this is very typical. So in this case, there's a temperature log here. You can see the temperature inflection here. This humdinger of a leak, it shows up on temperature, but this one down here, which is much smaller, it's just these drips coming out. Doesn't really show up on the temperature at all. It's not clear, which is quite typical. So if you want to rely on a temperature log only, would have missed that. And you never really know if this is due to a leak or some other formation activity or whatever happening here. So anyway, a very nice example, graphic example of what's happening. Other examples of cross-flow, lots of pretty colors here, but essentially there's a leak point up here, it's flowing down behind the pipe and flowing into some thief zone down here. And this well is under injection. There's two different rates, or there's an injection rate here, there's a shut-in. This is just different panels to look at the data. But there's a cement top right here. So there's a lot of information that can be extracted out of these logs to complement other things. So it will also be helpful to have a CBL log as well, and even the EM log through here. But again, I don't want to go to all the details, but just to highlight that noise is very good to look at behind pipe. This is another little example I have, which is related to distributed fiber optics, and it's a temperature log on a very deep gas well. There was known to be a tubing leak because there was annulus pressure on this well. They had fiber optics. This is temperature data. From the temperature data, you zoom in and we could see what looks to be like three hot spots in the well here in the temperature. So here, the well was shut in. They went ahead and opened the annulus. Right here, we can start to see some cooling going on here. So there was appears to be a leak At the bottom of that, there's this in an acoustic log here, and this clearly identified a connection leak here, here, and here that tied in with this log. So in this case, it was a combination of both, where the fiber optic data allowed the whole well to be surveyed. So it's a pretty deep well. If you wanted to log the whole well with a typical logging tool, it would take a long time. Here, you could identify this very fast, and then this was a very short, obviously, log over that interval to identify exactly the leak. Unfortunately, they when they went in to repair this well, there was other difficulties, but that's another whole story. So changing subject now. Now we're talking about through tubing measurements. This is using magnetic measurements, so a different type of measurement now. This is looking at tubing eccentricity and casing deformation. So again, looking through the tubing, trying to understand what's going on in the casing behind, or how the tubing is inside the casing. So what I'm showing on here is a section of the well here, where outside is kind of faint, but the outside is the tubing, is the casing. This is the tubing inside the casing. It's kind of a zoom in here, and you can see this is the outline of the casing. This is the tubing, and we can see some kind of buckling and some other problems happening inside the tubing. The tubing sitting right over to touching the casing through here, and we can see in this case right here, the casing itself has been severely damaged through this right at this section of the wells right here. So the tool is inside, where we can see the tubing and we can see the casing outside, and it's been essentially squashed, the casing. So you can look at casing ovality, you can look at tubing buckling like we have here, and also the eccentricity inside the casing. And this can be helpful for wells where you have, so this again an example where the well had significant problems. The actual casing was completely broken right in there, and there was the casing itself had sheared over, and we had significant eccentricity, and it flipped over 90 degrees through there. So it's but there was also severe casing deformation through there. So the casing has been deformed. That's caused localized problem with the outer casing has been deformed, and the inner casing has been stressed to the point it's actually broken at this collar connection right in there. So a pretty extreme example of kind of geomechanical forces that can occur. And this is just connecting things together. So, one of the difficulties with all the type of through tubing measurements, looking at corrosion, is that geometry is very complex. You've got tubing inside casing. Where that tubing sits has an effect on all the measurements around the tool. So in this case, this is an example where we have this kind of EM type of measurement through here, and we have this deformation information through here. We can see this zone, the tubing is some buckling going on. It's been pushed over to one side, and we can also see that on the EM log. This kind of blue section through here is due to the fact that the tubing has been severely accented inside the casing. And that could be helpful, if you're trying to understand, your centralization of the tubing, trying to understand, this type of log itself. We want to understand what's happening in these measurements. So by combining together, we can have a better understanding of what's happening behind your pipe. So it's just a kind of a flavor of some of the measurements that are out there for through tubing. So that's, small tools that run through tubing to be able to measure beyond the tubing, looking at casing, looking at casing beyond casing. And why is that important? This is a little bit of an old slide, but this relates to well integrity problems and the fact that there was a survey. I think this was done a few years back, but a significant number of wells globally, with various types of well integrity issues. You've probably seen that. And the fact that fixing those is a extremely costly endeavor. What we see, or what I've seen, is a lot of reactionary approaches to well integrity, waiting till there's a problem and then going out and trying to fix it. And that's, invariably where, invariably too late sometimes, and costly. I've seen cases where customers have come and said, can't actually even, pass a tool through the tubing, but they want to evaluate what's going on outside the casing. But at that point, the tubing's so badly pinched off that it's really too late to even get a tool through there. So there are measurements that can be made more on a proactive way to try to understand what's happening before it becomes a problem. So as a quick summary of what I've been through, there are EM type of tools that can look at corrosion and look at the metal and evaluate the metal through various layers of pipe. Leak detection, if you do have a leak and you do have abnormal pressures or you have cross flows happening behind pipe, there are tools for that. There's tools for looking at the geometry of the tubings. So you can look at, deformation in casing. This is, we have I have a case or an area of the well where they have, salt that is creeping, that's causing the wells to be deformed. It's an earthquake active or an active earthquake area. And, every time they have an earthquake, these wells shift even more, and to the point that, they can't enter the wells. And so, by able to do through tubing monitoring of the deformation, they can get a sense of how quickly things are, and they will then do a P&A before the well has got to a point that they can't enter it anymore. So we see, as I mentioned earlier on, there's a lot of orphan wells, a lot of wells that at the end of life, and P&A is going to be becoming more and more important, over the next 20 years, as we need to deal with, what we've already produced. And so making measurements to minimize your, or to streamline your P&A programs is helpful. And what else is coming? We think there are other possibilities for through tubing measurements. We haven't talked about cement evaluation or barrier isolation through tubing. So particularly in the P&A market, if you want to verify that before you go ahead and plug everything off, that your casing is well cemented or it's well isolated hydraulically, then currently you'd have to pull out the tubing and run logs inside the tubing. If you can do that through tubing without having to pull out the tubing, then you can potentially save a significant amount of cost there. So this is actively being worked on. I mean, it's a complex problem, requires low frequency acoustics to do that. problem what people want to look at azimuthal measurements as well, not just a simple CBL type of measurement, but they actually want to get an idea of how well the casing has been bonded. So that adds to the complexity of these type of measurements. But these are coming. Another is these other measurements I mentioned before for through tubing. Look at the average corrosion around your pipe, right? So if you can imagine in your casing, you've got a hole. If you take the average wall loss around 360, a hole will not be 100% wall loss. It will be less than that. So if you can actually image and get a image of the second casing thickness, then that improves your corrosion measurements through pipe. So that's also being actively worked on as well. So that ends my presentation. So hopefully that was quick and not too many squiggly lines. Any questions?
Hello.
All right.
Thank you, Marvin, for your presentation. I'm Rourke from Chevron. I like the idea, and I would like to ask you about the limitation of the technology. Apart from the buckling or the eccentricity, sometimes we have the problem with the hole size, the temperature limit, or maybe the gas well. We need to do the fill water before do the electromagnetic lock. Or maybe the footprint on the surface, can we do it at offshore?
There's a lot of questions there. But there are always some limitations, right, in these logs. The EM logs are not affected by fluid, so gas wells is perfectly fine. For footprint, that depends. Some these measurements can all be made on slickline units, so that reduces your footprint offshore. Temperature, yes, there are some temperature limits. Some of these technologies are available with a flask to go to very high temperatures. So, so there are solutions to some of those problems. For the temperature, you mean? Well, if you put a flask on it for geothermal applications, it can be 300 C or above. Yeah, so whether it's noise or whether it's EM type of tools. Does that answer your question? Yeah. Any other questions?
Any question from the back?
No, it's good. Everyone's busy eating.
Once. Two.
Oh, so
Any questions for Kun Marvin?
well, I have a question, maybe in reverse. Maybe I can ask a question then. Because the Allison Canyon well, how many people actually knew about that? One? Okay, it's one or two, right? So, and that was it was not as well published, even though they were publicized in the media. Though it did capture some media. Of course, Macondo was a movie made out of it, so everyone has probably seen that. But for every one of those that you hear about, there is many more that let's say fly under the radar completely. One of the things with well integrity is all the examples I have here for me are good examples, but for the operator they are bad examples, right? No one really likes to air their dirty laundry about problem wells, and so that's always the challenge is to admit that there are problems. But so places in the Middle East, I know many cases that the only place I've ever seen heard about is, some guy on Facebook has recorded a video and posted it on Facebook, and that's about as much of the incidents. You see a fire at the well site. You've probably seen some of those on LinkedIn as well. No one really knows the story behind them, but for every one of those well integrity problems, there is there is obviously a root cause. The one that I mentioned here, it took them 2 or 3 years to go through and a very detailed report, but the actual conclusion is pretty straightforward, and it could happen in pretty much any well, anywhere, the same scenario. So I think the message that I've seen, or what I've seen, is that unfortunately the well integrity, attention paid to the well integrity increases 100-fold after there's been an accident, and it's and it's unfortunate that that's the case. Regulatory requirements are catching up in certain areas of the world, and particularly in Norway and UK, offshore North Sea. They kind of lead the way in the well integrity standards, but I see that not being uniformly applied around the world. And in this case of the Allison Canyon, that was in California, and we see now a particular attention paid in just that one state, and it hasn't even hasn't propagated really across the country, even though it could happen anywhere. So anyway, so if you have any well integrity logging related questions, I'll be here afterwards. So thanks for your attention, and appreciate the invitation to speak.
I'll ask you to do the honor for the lucky draw. But okay, yeah. Sorry, it's my first time, right, being an MC. So can we have Kun Ron from SPWLA to present the token of appreciation to Kun Marvin? Yes. And do we have the photographer ready?
We're all stand over here.
Yep. One more, two more. So thank you very much, Kun Marvin, for your excellent presentation. And thank you to SPWLA and SPE Thailand as well for preparing a very nice token of appreciation. Right, so I don't have the clicker, so I will have Pinet to help me to move the slide to the closing remarks. The next slide. So before we go to the lucky draw, there are some announcements or advertisements. Right, so please mark your calendar for the next month in October on Wednesday, 26th of October. So we are combining our season opening and our EMP Awards dinner. Kun Montri, the CEO of PTTEP, will give a talk on the next chapter of Thailand Upstream. And we'll announce the winners of our SPE Thailand EMP Awards during the same session. We will serve dinner at your table in the Landmark Ballroom, which is the same hotel, and run a very relaxed program while you're enjoying your meal. Please register online first come, first serve, and we will email the announcement shortly. And I hope everyone is aware now that the IPTC will be held in Bangkok next year from 1st to 3rd of March, hosted by PTTP. This will be a large conference with many visitors from overseas, so please put it in your personal development plans and include your attendance in your budgets. And also, please check out our SPE Asia Pacific website with our upcoming events, www.spe.org. Many workshops, symposiums, and of course, we have the Asia Pacific Oil and Gas Conference and Exhibition, APOGCE, in Australia next month. Now, the next slide here. There are many ways to get in touch with SPE Thailand section. So, as I mentioned earlier, you should update your membership in spe.org to Thailand section. I did that. If you do that, you receive regular emails, right? Official emails from the SPE Thailand. And please follow and like us on Facebook at Society of Petroleum Engineer Thailand section. You can scan also the QR code here. You can look us up on LinkedIn as well and join the SPE Thailand section group. And we also have a Line official account where you can just scan this QR code and you can follow our upcoming events. It's not a group. You just receive announcements from the SPE Thailand committee. And it's very convenient. Like, we send you links, you just click and register for the upcoming events. So please scan any of these QR codes. And if you need help, just reach out to any committee members to connect to either our Facebook, LinkedIn, or Line, whichever that is more convenient for you. Unfortunately, our Thai SPE.org website is still down. The web hosting companies have several technical difficulties. I mean, there are a lot of challenges, and I participated in some meetings as well. I can be the witness that the Thailand section committee is working very hard to bring it back online, and we'll work on that. So meanwhile, please keep in touch with us via Facebook, LinkedIn, or Line. And finally, our lucky draw. So can we have Kun Marvin in front of the stage again to help us with drawing 2 winners. So the prizes are sponsored by SPE Thailand section and in appreciation of your attendance here tonight. So let's have the first lucky winner. Picture, we have photographer. Yep. Photographer is there already. Kun Alex Bevis. Congratulations, Kun Alex. Can we have our next lucky winner? Dum 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 dum. Oh, Kun Stephen Kokosa. Sorry if I pronounced wrongly. Kun Stephen, congratulations. Relax, female. Right, thank you very much, Kun Marvin. Now we have only 2 slides left, so please bear with me. As usual, we have the thank you for coming for our SPE event in this venue. Feel free to finish your drinks here, and if you still want a couple of more drinks, we have arranged a special SPE Thailand drinks at the Rendezvous Bar at ground floor lobby level of this hotel. So tell them you come from SPE. The secret password is SPE, and they will offer you 2 drinks. They have never asked me about password. Who wrote this script? So tell them you came from SPE, and oh man. So they'll offer you 2 drinks for the price of 1, right? So yeah, 2 drinks for the price of 1 at the lobby, and we'll see you there. One last slide. One last applause to all our sponsors. And updated. And thank you for being here tonight. We hope to see you next month on Wednesday, 26th of October. Have a great night. Thank you. Cup. Thank you. Next month we will have Kun Panit.